In part 1, we designed the all-sky enclosure on my hosted site, but you don't have to rely on my slow server. In this video, I'll show you how to run the exact same SkyForge tool locally on your own computer with Python, offline, private, and yours to tweak or extend. If you haven't designed your enclosure yet, start with part 1 to get an overview of the design tool. Otherwise, let's get it running on your machine. So to run the design tool locally, you're going to need to download Python. Python is a free scripting language application that it's available for all platforms, Windows, Linux, Mac. We're going to just show a Windows install right now. So make sure when you download it, remember where you're installing it at, and then kick off the installer. Now the important thing is make sure you check the bottom option, add Python to path. If you don't, you try to run it from the command line, it probably won't run, or it'll pop up with the Windows Store and it'll prompt you to install from there. You don't want to do that. This gets kind of messy. So make sure you choose that add path option and then continue. Once it finishes the install, we'll do some sanity checks on it, make sure we got the right version. And you'll see that right now we're downloading 3.14.6. So we want to make sure that when we check our version that it actually matches that one, because you may already have an install of Python on your computer, but you just weren't aware of it. Close to that, we're going to go down and bring up a command prompt, so you can type either command, the word command, or type in CMD Charles Mary David, hit enter. And at the command prompt, we're going to type in Python -- version. And you see that Python 3.14.6 is what we installed, and that's what we're showing our current version to be. So we're good to go on that. Okay, so we have Python installed. Now we are ready to download the Python scripts that will run our SkyForge software. So to get those, you go to washitaobservatory.com/SkyForge. And I will have a link to this in the description because Washita can be awkward to spell sometimes and don't want you to get bad addresses. So there will be a link to click on in the description. It'll take you to the site if you can't remember what the link was. So hit enter, and then when we have this page, we'll say download SkyForge. You'll be prompted for a location. I'm just going to drop this into temp. So SkyForge, it is a zip file. Now, if you get prompted by your web browser that it's not safe, some web browsers have additional security that may say zip files are not safe. They're safe. They're just compressed files with additional files inside of it. So just choose to keep it if you're prompted. Okay, so we've got it downloaded. We will go ahead and open it. Say SkyForge. And then you'll notice, depending on which zip extractor you're using, you'll see that there's already a folder in there called SkyForge. So if you hit extract, it should drop it, the entire folder, wherever you decide to drop it at. So like on Windows, you may have a C or a D drive. Mac or Linux, you may have different volume names. So we're just going to put this directly into D. No additional folder structure. This folder structure will carry over. So we'll say D:// OK. Okay, the file's been dropped out. Now let's go to our D drive, make sure it's there. Yep, it's there. Okay, so we have all of our assets that are needed to run the script. The main one that we're going to work with is this allsky_GUI.py. These other py scripts are basically just the assets that help generate the different components of the model. Now, one thing I will say before you run any py script, especially that some stranger on the internet offers you, take these and run these through your favorite AI agent, whether it's Gemini, Claude, ChatGPT, because Python is a very powerful scripting language, and bad guys can do bad things to your computers by just, if you run these on your machine and you really don't know what the contents are. So you just consider these things to be possibly viruses, malware. But I'll assure you mine are clean, but don't take my word for it. Go to Gemini, Claude, or ChatGPT, drop these files into their processes and just ask them, hey, is this file safe? And they will analyze it and tell you, yes, it's completely safe. It's some weird all-sky enclosure generator. So that's what you should get anyway, something along those lines. Not maybe weird, but awesome. Anyway, so we are going to jump out. We've got the files we need. We will jump out to a command prompt. We will change to the SkyForge folder. Okay, one more thing we need to do before we try to launch our SkyForge software. We need to install some dependencies, basically little applications that will be running to help make sure everything looks correct. So at your command prompt, we're going to be in the folder where you extracted it to. we're going to type in pip install -r, and we're going to type requirements.txt. Now, the requirements.txt basically just tells the Python application what modules do we need to have pre-installed, and you only have to do this one time. So you'll run the command pip space install space -r space requirements.txt. You'll hit enter. Okay, so now that part is done, and we'll move on to the next step. And now here's where we will run our Python command. So we're going to type Python, and we're going to type allsky _ GUI.py, GUI.py. Okay, hit enter, and this will launch this SkyForge interface, and you will get a disclaimer, just basically me telling you that the software is provided as is, and I don't guarantee any of it, but I have to do that because legal reasons. So I accept. All right, so now we will explore the interface. Okay, so we're in the interface, and one thing I forgot to mention, when you run the SkyForge command, you will get this message that actually shows the application running. Do not close this window, because this is your local web server that's running that supports the SkyForge interface. So if you close this window, then next time you click on any of the options in the screen, you'll get an error message. So make sure you leave this running. Now, one thing to notice on here, this is running on your local host address, which is your 127.0.0.1 port 5000. If you already have something running on port 5000, I guess just message me and we'll have to figure out another way for you to run it. But most people don't have anything running on port 5000 already. That's why I chose that as kind of a safe port. So let's look at this interface. Whenever you're moving around on this interface, you have different options. So you have your tube system, you have standard or tall. So depending on if you click the standard option, you get all the standard tube accessories. If you click tall, you'll notice these change. These are all the taller accessories. You have the option to generate the STL. Once you choose your option, it'll pop up over here. You have the option to reset any of these parameters down here. If you change something, you're like, messed it all up. Let me just start over. Just hit reset params. And then finally, you have the option to download individual models. So if you generate, let's generate this head cap. We'll say generate, and then I just want to download it. So we'll hit download, and then you see you can pop it into your whatever folder you want to save it to. Let's see, if we adjust some of these parameters down here, cap outer radius, that's basically the thickness of the cap. It's not going to adjust the threads, it's just going to adjust this part. Cap skirt, say you want it to be longer, you don't like where the holes are at in the neck of the tube, and you want the cap to be longer, you can adjust that. Just get around there and play with it. Just be careful on adjusting too many settings, because you can wind up with something that may not be completely compatible. Let's look at the interface. If we're looking at this, you have ways to move these things around. If you left click, it basically it's kind of a free view. You just click around, drag. You're just holding the left mouse button up and down. I'm dragging all over. You can see how I'm kind of just moving my mouse around. If you want to pan, basically you just right click. I'm right clicking the mouse, and this is just a pan left and right. If you want to zoom in, just scroll your mouse wheel or hold your mouse wheel, the middle mouse button, and then drag forward and back. So we're doing that. Now the slow zoom in is just to roll your mouse wheel. If you have a mouse middle button that's a wheel, just scroll back and forth like that. There are some quick views up here. You have an isometric view, just puts you up at an angle looking down. You have a front view, which on this cap, everything's going to look like a front view because there's no real shape to it. Top view, we'll move that back and forth, pan it up, and the side view, of course, that looks like the front view because it's round. So the other thing that you may find interesting is this wireframe view. This allows you to see into it, so you can see through the polys on here. You can kind of zoom in, you can see where the threads actually start on the cap. If this is useful, especially if you've gone into the model view where you can see how the things connect together. Of course, the model view does do a transparency on the different components. And we'll jump into that in just a little bit. See the underside, see where the threads are. And one thing to notice, you'll see these threads, there's multiple starting points on these threads, so that gives you the option to have a quicker tightening. A 27-degree turn completely tightens this lid down. So you have a thread start there, there's another one there. Where some screws, you have one single start thread. This has 3 different levels where it can start at, so it just allows you to start tightening things faster. Okay, so back to the overall design. Let's look at some things that you can do with this. If we go to the standard view, we've already got a head cap and it's got a dome, transparent dome that we already have on there. This is just for visual purposes. Obviously, it's not going to print the dome for you. You have to buy that on Amazon. And I do have the part that this is modeled around. But you can also use a different dome. If the dome has a different diameter, you can actually change the dome seat on here, the dome hole radius. So you can actually change that. If we change that to say, let's do some crazy number. Let's make it a really small dome. We'll say 32. And we'll say generate the STL. And then there's your smaller dome. So you could, or dome hole radius, and then you could put a smaller dome on that. And then you have your smaller dome seat radius where you could bring that in. So this is the dome seat right here. So obviously we've extended past that. We need to bring that in. We'll say that dome seat radius will be 35. And you'll notice up here, if you type in a value that's not compatible, it'll tell you you can't do a 3mm dome seat. That would just not fit. So we'll do a 35. Hit generate STL. And now you see your dome seat fits right onto the edge of that. I know there's multiple sizes of domes that you can get for these things, so I'll try to make it compatible with everybody. All right, so let's reset this because we're just going to model this as a standard configuration. So reset the params, generate the STL again. We're back to defaults. Now we like that dome. We'll add it to our model. So we've got our head cap in our model, and I'll show you what this does in a little bit so things will make more sense. Now let's go to our head tube. So this is a standard head tube. It's not the full. It's not the tall one that you saw earlier in the video. We'll say generate the STL. And these tubes do take a little bit longer to generate, depending on how fast your machine is. If you've got the power of an Etch-a-Sketch, it's going to take quite a while. If you've got a supercomputer, probably not going to take very long at all. So this is our standard tube. You'll notice we have the vent holes, which you will want to put screen on the inside of these so that bugs can't get in. And then also on the bottom, this bottom ring, just the outside. And there are templates that will be included in some of the zip files for the actual STLs, for the default builds, that you can print out so that you have a template to cut your screen with. So those are included. It just makes it a little bit easier to have a kind of a donut ring that you can cut your screen around those and be able to drop it in and glue it so that keep the bugs out. So, and then inner side of the vent rings here. So everything looks good on that. We are going to add that to our model. So now we have a head tube, a head cap. Now we got to choose our cradle. So a lot of people will probably be either running in the Raspberry Pi high quality cam or the ASI 676, one of the puck models, the kind of the planetary models. So we're just going to go ahead and choose that one. We'll say we could generate the STL, but what we really want to do first is we want to put a lens on here, because when it generates the STL, it's going to put a mock-up of what the planetary camera looks like, and we need to try to put a lens on there so we can see how high it sits under the dome. So whichever lens you're going to use, try to get the specs on it, basically how tall it is from the seat of where it screws into the planetary camera. Most of them I've seen are around anywhere from 25 to 35 millimeters. So we'll just do somewhere in the middle. We'll say 30 millimeter lens length from the mount on the camera. And then we'll hit generate STL. Okay, so here's our imaginary planetary camera, and here's our little lens that we chose. We did a 30 millimeter lens on that. Now we will add that to our model. So we have these three components. One last thing that you do want to include on here, you want to get your do ring on here, because the do ring kind of sits a little bit above this threaded ridge right here. So we'll go back on here and make sure you grab the do ring that's for your model. Obviously, we don't want to grab the ASI 533 do ring because it's a pretty tall do ring. That's a full-size Astro camera. We'll grab the do ring tray, generate STL. And there's our do ring tray. And you'll notice on here we have the holes, like I said earlier in the video. You can do a DIY resistor on here, like 4 or whatever ohm that you set, or you can just buy one. I think do control is a pretty popular do ring, and you can buy one of those and just not have to worry about using the soldering iron. So we've got that set up. Now we're going to add that to the model. Now we have all these options on here. This is basically a full setup. Now what this is for is to give us a view to see how high the camera is sitting inside the dome. there's usually two camps that I see with people that build all sky cameras. Some say, make sure the camera reaches all the way to the top of the dome. Some people say, let it sit just above the ridge of where the dome is. And I sit right in the middle, and I don't have any reflection problems, but I'm also in a dark sky area, so I don't have to worry about street lights coming in the side and casting a reflection. But let's go ahead and model it. So now here's all of our components stacked inside of your all sky enclosure. So you can see kind of where our camera is sitting at. Our lens is sitting about halfway. You could actually increase that on your cradle. Say you're not happy with it sitting down this low, or maybe it's sitting too high for you. Maybe you're the camp that wants everything to be sitting down real low. You can adjust this cradle on here. You can basically just go back to your cradle, and it will generate it, and it'll replace this. We can go back and model it in a second. Okay, and you'll get some messages on here basically telling you different parameters of how high certain things sit, where the camera sits at, things like that. But what we're interested in is we want to raise that seat. So that camera, you can use the plus to raise it, negative to lower it, and that's basically pushing this part up. So if we say, I want that camera to almost touch the top of the dome, let's raise it up by 20 millimeters. And then we will go down, make sure there's no other parameters, everything's good on that. Generate the STL. Okay, and now it's been raised up. So now let's add that to the model, and it will automatically replace the existing model that you have in there. You don't have to worry about closing it, clearing it out, and then adding the new one. So just hit add to model. See that flash green, it threw it in there. We'll hit model it. Now we are very close. Also keep in mind when you're doing this, your dew tray is raising up too. So make sure that you've considered that, because otherwise when you build your cap with your dome on it, this dew tray may actually touch the edges. And I may work on a solution around that, but it's kind of the whole thing is just moving up there. Maybe the solution is just to get a taller lens. Wish it was that easy. Anyway, so that's how that works. Oh, and for reference for size, if you're trying to target a certain size, these domes, these enclosures can be made shorter. Basically, I'm building it around my 533 design, where I have a very tall camera, and the rest of the world uses those too, in my imagination. So everybody gets a tall enclosure. Not everybody probably wants a tall enclosure, but you can reduce that. So if you want to go back into your cradle and you want to take off a few inches, millimeters, whatever, you can do that. Just make sure if you change the enclosure height, you also change the cradle height. But you would see that when you modeled it, that the enclosure was, or the cradle was sticking outside the enclosure. But if you want to see the scale for it, just add a soda can, and that's basically the height that you're going to see. Now on the standard view, it's not that big, but on the tall one, it's a pretty chunky enclosure, and I have no issues with that. I'm proud of that big boy. Anyway, we'll show that one in just a little bit. So that's pretty much how you do all this. Now, if you want to export the PNG of this view, you can do that. It'll take a snapshot. But if you're ready to save the STL files, go ahead and hit Save STLs and Photos. It's going to take a couple snapshots for you, so it'll save those to the file, and it'll save all your parameters that you did. This way, if you go back and you want to rebuild this exact same thing tomorrow and you've already closed out your browser window, you can just re-input all those parameters. So we'll put this in here, Terrible Designs, that sounds appropriate. And we'll pop that open, and then here's all your images. Here's your specs. So if you wanted to see what each one of these were, just double click your specs. Ouachita SkyForge, here's your design tube. This is all the parameters that you had. And basically that just kind of shows you everything that you configured on that build. Your views, if you want to see each one that it took a picture of, you can pop those open. But you can just extract this zip file to your folder, wherever you're going to be printing it from. So, and that is that. Here's the tall build. If we go to the tube tall, I'll just give you an example of how big this one is. But this does fit my 533 perfectly, and that's why it's this tall. So I'm going to clear all those out. We don't want those in there. And if you try to leave those in there, you try to model it. Obviously, you can't use a short cradle or a standard cradle inside the tall tube. You have to do a tall cradle in the tall tube, and it should give you an error message. So anyway, we will add this to the model, and then let's say model it, and you see the height on there. It's about twice the height of a soda can. Other options that you do have on here is we could engrave your cardinal points on there. This is more of a novel idea because sometimes when you get your camera inside there, they may not exactly line up with the northeast southwest. If you're lucky, they might, but I put it on there thinking I was going to be able to do it, and it didn't always work out for me. It really depends on how tight you get this on there. If you can adjust your camera inside the body to be true north. With the pup camera, since the USB connection is on the side, there is room for you to adjust it, but on the 533, the connections come in through the bottom. So there's kind of a template where I've got cut on the cradles. Let's generate one real quick so you can see what I'm talking about. Okay, so on here you see these little holes cut out. These are basically like the fan of the 533, the power port, the USB connections. You're kind of locked in. You're basically, your camera's going to be sitting in this direction, and if these threads tighten up early before you're able to rotate your top of your sensor to north, then you may not be looking at exactly north. Anyway, that was just a little caveat to that. Let's see, go back to the head. And also, one other thing I forgot to point out was on the tube, depending on what you select on here, these parameters change. So if you're tube length, if you choose tube, you're going to get tube length. If you choose cradle, you're going to get different parameters on that, raise and lower the camera. And so this way you don't get confused on different settings. And that wraps up part 2. You've now got SkyForge running locally and your print files are exported. Ready for the hardware? Part 3 is already up, and it's the brain of the whole thing. Choosing your Raspberry Pi and flashing its OS with a Pi imager. Grab a Raspberry Pi, a micro SD card, and a card reader, and click straight into part 3, linked right here. The full series is live, so you can build the whole thing start to finish. If anything tripped you up or running it locally, drop a comment. And thanks for watching. I'll see you in the next one.